All right, and I think most all of you do have your cameras on. That's good. Now, if your camera is broke, you have to let me know because I can't give you credit for attending the class if you're not talking. If I can't see you, it's really hard for me to know if you're there or not if the camera's not working. If that's the case with you, that's fine. Just let me know. That's not going to be a problem. But otherwise, yeah, you should. Have the camera on, that way I know you're here and you're paying attention and all that kind of stuff. So right, all right, I'll do my screenshot thing here. Okay, so yeah, so today we're going to get into the first thing I'd like to do before I start talking about the data recoding, because that's the main thing we want to do today. We want to I want to show you 3 different examples of how you recode data into a different format using some set of variables. Before we do that, I'd like to talk to you about the slideshow that's on descriptive stats. I just want to go over that. I want to bring that up. Let me mess around this for just a second so it shows up here on my screen share. And I will want to go over that with you. Yeah, so this is on Moodle. Just someone give me a thumbs up that you can see a PowerPoint slideshow. Okay, great. Thank you very much. Yeah, so today I just want to talk to you briefly. We may not go through this whole thing because I do want to get to the data recoding. But part of your homework is you want to run your first statistical results table, a frequency distribution table. And so what a frequency distribution table is, it's really simple. All it is, it's just the number of times a particular attribute on a variable is observed, or a particular level of a variable. And so if you had a question like this, where it's how many times have you attacked somebody with the idea of seriously hurting them? That was an actual question, a survey I worked on years ago when I was working on my dissertation. So we asked this of a bunch of kids, and most kids, of course, say no to this, but some do. And this is just made up data. So if you had a sample of 100 individuals, 40 of them, or 40%, would say, no, I've never done that. 30% or 30 said 1, 15 said twice, 10% said 3 or more times, and 5 of them said 4 or more times. And so that is a frequency distribution. That's all it is. It's just showing you what percent of the sample said never, what percent of the sample said once, what percent of the sample said twice, what percent said 3 or 3 times, what percent of the sample said 4 or more times. And that is usually the case, is that whenever you are doing any sort of statistical analyses, you always want to start by running a frequency distribution on the variables that you're interested in. So you know what the distribution is. So you can see, okay, just what percentage of my sample has said that they have never seriously attacked somebody with the idea of seriously hurting them. What percent has said that? Said no. What percent has said that they've done it all, or what percent has said they've done it, 4 more times? So these are one example of a basic descriptive stat that it's quite normal and really kind of just, you have to do this, is you always want to run a frequency distribution table on your variables before you do any other sort of recoding or do any other higher level stats with them. Before you start putting into a regression analysis or anything like that, you want to know what the distribution is. And so, and you can also then check your work when you do recodes to make sure that the distribution is what it should be. So this is a frequency distribution table. It is usually the first type of descriptive stat you would ever want to know. So it just tells you what percent of people fall into what categories, or what sometimes is called attributes on a variable. And so the attributes of this variable would be never, once, twice, 3 times, 4 or more times. Sometimes it's called level of the variable. But if you have a nominal variable like gender, it wouldn't make any sense to say what level of gender do you have, or that. So it's an attribute is the more general term to say what, at what point of the variable, where do you fall on the variable scale. There is, of course, variation around the average score, or there's variation around the median when you look at a large distribution of people, not not a lot of people will have, or no one might have the exact average. There will be a range and distribution of responses for variables. By definition, because variables are things that vary across observations, that's what makes them a variable. And so if you look at something, again, like how often the past 12 months have you attacked somebody with the idea of seriously hurting them, never, you could do it by never, once, twice, 3 times or more, 4 or more times, or you might want to measure variation in a more detailed way. You could do it in exact numbers, like you could ask somebody how many times exactly. That's another way of measuring variation in a response to a variable. Or you can make it really simple, and this is one of what we'll do in the exercise. Have you ever done this? Yes or no? And sometimes when you're asking questions where it depends on memory, on people's memory, and memory is not perfect, sometimes what's called a dummy variable question or a binary coded question, yes or no, sometimes is a sufficient to capture the variation. Because if you ask a too detailed a question, if you put the question to a bunch of 16-year-olds and ask them how often the past 12 months have you seriously hurt somebody, then they might just be guessing at numbers. That you're pulling variation out of the air that doesn't really exist, and it's not accurate. So sometimes the simpler way of getting at the variation in response to some variable is the best way to do it. Not always is the very simplest way to do it, like just a yes/no response, but sometimes you want to do that, and we'll show an example today of how to reduce something that's has more variation in the responses, and we want to crunch it down. We want to collapse categories and make it into a dummy variable or a binary yes/no type response. Another big term when you're talking about descriptive statistics is something called central tendency. And central tendency just says where most of the observations fall in the distribution of the data. Oftentimes when people talk about central tendency, they'll talk about the mean or the average score. And so if I measured all of your heights, you would have an average height for you guys. Now, nobody in the class might actually have the average height. It's a statistical abstraction. No one is really exactly on the average, but a lot of you would cluster around the average. And so the average is just the sum of the total scores divided by the total number of scores. And so that's just mathematically showing that there of how you have to how you would calculate a mean or an average. So all it is the sum of the scores divided by the total number of scores, or the total number of cases. And so here the total would be 110 divided by 100. So the average score for this response would be a 1.1. And so and then you could interpret that the average person in the sample has said they got into a fight about 1 time in the past 12 months. So that 1.1 is meaningful. And you can look at that based on the original scoring that goes from 0 to 4. And 1.1 means that the average kid is saying that they have gotten into a serious physical fight about 1 time in the past 12 months. Another measure of central tendency is what's called the mode. Now, the mode is the most frequently occurring score. It's the most popular response given. And so in this data set, since 40% of the respondents said that, no, I have never done that, which is higher than any other, it's more populated, it's a more popular response than any other response. So in this case, 0 or never would be the mode. Because that's the most popular response given. So the mode tells you the most popular response, okay? And then the last measure of central tendency, there's only 3 of them, is what's called the median. So there's the mean, the mode, and the median. The median is just the midpoint. It's the exact midpoint that splits the distribution into about 50-50%. It's right in the middle. And so if there's an odd number of cases, the median is simply the middle number, and the 50% lies above and below. And if it's an even number of numbers, you would just average the two numbers together, the two middle scores together to get the median. So the median is the exact middle point of the distribution. If it's a normally distributed variable, then the mean, median, and mode will be very similar in value. They'll have about the same value. That's not always the case. Not everything forms a perfect bell curve distribution where most of the people sort of cluster around the average. It may be a really skewed distribution, and so it's not always the case that they'll match up. But oftentimes you'll hear the median reported when you're talking about median housing values. And so that means, about half of the people fall below that level. Another half of the population falls above that level. And so that's what the median is. It's just the middle score. And yeah, I'm saying here, if there is an even number, you need to average the two middle scores. And so in this case, they're both the answers would be 3. So that's your 3 major, or really only 3 measures of what they call central tendency. That is the tendency for scores to pile up in the middle of the distribution. And so that's the mean, which means the same thing as the average, and the mode, that's the most popular response given, and then the median, that's the middle score. That's the one right in the middle of the distribution. Okay. There is also something called dispersion, and this is also related to the range or the variation of the scores. And so usually we want to, in addition to reporting on a frequency distribution and some measure of central tendency, we want to know what is the minimum and maximum values for any given variable. Like what is the range of your variable? What does it range from? 0 to 10, 0 to 4, 1 to 100? That's one measure of dispersion. So how high and how low can you go on a particular variable? One that's a little bit more complicated, but not too much, is something called the standard deviation. Because like in the example, if I would say I would measure all of your heights in inches, not everybody, I should say this, no one in the class is going to have exactly the average height. You're going to vary around that average score. And the average distance from the sample mean, or the average distance from the average, is what's called the standard deviation. So it's saying, how different is the average person from the average height score in this class? And you might find that the standard deviation is like 3 inches. So the average, you have something, 60, maybe 60 some inches, and you get variations around that score by about 3 or 4 inches. And so some of the males would have maybe a standard deviation or 2 above the mean. The females usually be a standard deviation or 2 below the mean score. But there's always a standard deviation. Whenever you report an average, you're usually going to also report a standard deviation, because there's no one single case in your data that probably even has the average score. People vary around the average, and the average difference or distance from the average score is the standard deviation. And what you're seeing there is the actual mathematical formula for finding that. And so S, or the standard deviation, is equal to that little E symbol is sigma, or the sum of. It's the sum of all the observed scores, X, minus the average score, and the average notation is X bar. So whenever you see X bar, that's indicating the average. And so that's in parentheses. And then that whole thing is squared, and then it's divided by the number of observations in the sample. N always equals the number of observations. That's what N stands for, minus 1. So that's how you get the sample standard deviation. That's how you have to calculate it. Don't worry, in this class, I will have you you actually don't have to do any calculations by hand. If I have you do calculations, you'll just be plugging numbers into SPSS. But that is how you would hand calculate the standard deviation. But yeah, standard deviation is something that it is standard to report the standard deviation whenever you're reporting an average or a mean. And so this is here a little note that if you have a really big SD or really big standard deviation, that suggests the distribution is really spread out. That means that the average person really is quite a bit different from the average score. And so the average score may not be very informative of where the sample stands as a whole. If the standard deviation is really small, that means a lot of people, most of the people in your sample are really close to the average. They're really bunched up. Okay, so big standard deviation, that means the scores are spread all over the place. Most people don't have anything close to the average score. If it's a really small standard deviation, though, that means that a lot of people are clustering very closely to the standard, to the average. Okay, so the average in that case, when the standard deviation is really small, the average is more representative of the sample as a whole, as where people stand when it comes to physical violence, when it comes to their attitudes towards certain politicians, you name it, whatever it is. Small standard deviations mean that most people are clustering close to the average, that a lot of people are close to the actual average score. And this is something that we'll get into later. This is what's called a Gaussian curve or bell curve or normal distribution. And so if something is normally distributed, it will look like this. So you have X bar is here right in the center. That's the average. And if it's normally distributed, this minus 1s, 1s over here means -1 standard deviation below the mean, 1 standard deviation above the mean over here. And so this dotted line and this dotted line here, this will make up, in a normally distributed variable, it'll make up 68% of the distribution. Okay, if you go out 2 standard deviations, 2 below, 2 above, that will make up 95% of the distribution. And if you go out 3 standard deviations out to here, 3 standard deviations below, 3 standard deviations above, that will make up for 99.7% of the distribution. And it keeps on going. It's assumed to be infinite, that you can keep going out, that once you've found the tallest man on the planet, it's assumed that you're probably going to be able to find somebody who is just slightly taller than him, even by just a millimeter. So it's assumed, even though really it may not be true, you really may reach a natural limit to finding very tall humans, that it's assumed to always be, it's assumed to be infinite. The standard deviations keep going and going and going. So the tails never really completely taper off. In your observed sample, yeah, of course, you're going to find, okay, here's the tallest person, here's the shortest person, but in the populations, assume that that really it's the distribution is infinite, and you're just getting a sampling of it. Okay, so that is what's called, that's where this idea of the normal curve or the bell curve comes from. This thing kind of looks like a bell. So the idea is most people in this, if it's normally distributed, then most people are going to have a score that's pretty close to the average, okay? And then really a very small number of people will have something that's really below the average. Likewise, a very small number of people, relatively small number of people, will have something that's really well above the average. Okay, so a lot of people are bunched up around the average. That's what makes it a bell curve, that most people in the distribution, or most values for your observation, it doesn't have to be people. It could be the average length of a dolphin's fins. That's going to fall along a normal distribution. Most dolphins are going to have a fin that's this long. Some dolphins will have these really, really dinky, maybe because of deleterious genes, they have really, really small fins, and then some, because they have, some extra genes for growing long fins, will have really, really long fins, and they'll be out there on the far right-hand side of the distribution. So it'll still form, though, a normal bell curve type distribution, or Gaussian curve, named after this Gauss, the statistician who discovered this a couple hundred years ago. Okay, is there any, I should stop, is there any sort of just general questions about that, about the mean, median, mode, and frequency distributions? We will get into this stuff a lot more later, but for right now, I just wanted to give you a brief overview of that. The only thing that we're going to be doing for homework is just creating a frequency distribution, so you don't have to deal with any of this other stuff just quite yet. So I'm going to go ahead and exit out of that. I want to go and get out of this. Let me go back to where we're at. Okay, so the next thing we're going to do, I would like to go ahead and start with what you all are going to be doing for recodes. Okay, so I'm going to go ahead and share my screen with you again, and I want to, where is my SPSS? Oh, let me go in here just a moment. I'm going to open up Apps Anywhere. Hopefully this opens up right away without a problem. What I'm going to do is I'm going to open up SPSS, and I'm going to open up that Add Health data set that you have, that you can download that onto your desktop or your downloads folder, wherever you would like to do that. But that is what you're going to be using for these exercises. Well, that's what I'm going to be using for these exercises. What you're going to be using for your homework. So just give this a moment, let this open up, and we will start with that. Okay, this should be opened up now. Let me, okay. Let me get back to this. I want to just show you guys how to do this. All right, where is this at? Show all windows. Okay. Okay, so you should be able to see an SPSS spreadsheet now. Can you see that? Somebody give me a thumbs up. They can. Okay, great. See head shaking. Very good. All right. So what we want to do to open that up, after you've downloaded it from Moodle, File, Open, and then you always want to go over to where it says Data, data for opening the data set. So click that, and okay, so here it is. It's this 21600 dash. It's this thing, opening this up. Okay, oops, I know it said to stop sharing. Let's see, let me go back to that. Sorry, it does this sometimes. It's all of a sudden just inexplicably stopped sharing the screen. Okay, so you should be able to see that now. So it's opened up the Add Health data set. So it's opened up to where the variable view is. So remember, you've got your variable view and you have your data view. And so here's the data view. Remember, here are all your variables across the top. These are the columns, and then in the rows, you have cases. And so in the Add Health data set, we have, go all the way down here, we've got, what is it? It's like 6,004. Yeah, we have 6,504 respondents. So 6,504, and these are kids that were, well, they're adults now. They're older than you now. They were like about sophomore in high school back in like the mid 90s when they were first interviewed. And so that's who this is. It's a random sample, it's a large random sample of high school students in the United States. And it is representative of kids in the United States in the 1990s. Currently, these people are like in their early 30s, mid 30s is how old these people are now. So this was a few years back. But anyway, this is on the data view, and this is showing all the data. Here is the variable view, and so this is the variable names. And so this is the case for a lot of data sets. You will see that the variable names don't really tell you jack about what the variable is, what it was measuring. Some do, like here's BioSex, that shows you. A lot of times in SPSS, you got to go over and look at the labels, just pulling this open, and you can see what was being measured. Okay. So what I would like to do is I want to go and recode a variable. So it's a dummy variable coded. It's a binary coded. It's just a yes, no, a 0-1 type coding. And so that's called binomial coding or dummy variable coding or binary coding. It all means the same thing. What you can do to quickly find variables in this, if you click on this and you do hold Control F, you hold Control F, at least on the PCs, it'll come up with this little find replace. It's the same thing in Word. I'm going to look for this variable oops, back on my right screen down here. I want to look for this variable that asks about physical violence, and the name of the variable is actually H1 FV5, and I go ahead and hit enter, and that'll go right down to this variable here, and that tells us nothing about what the variable is itself. The label does, though. The label says got into a physical fight. Now, you can always go back to the original ad health survey and find this variable in there by searching for H1FV5 or just keywords, and you'll find it. And they just asked these kids how often they got into a physical fight in like the previous year or something like that. And then, if you recall how we measure this thing, we have to go over to where it says values, and we click on this, and this is how this thing was originally coded. Okay, so you have 0 is never, 1 is once, and then 2 is more than once. And that's how they coded it. And so it's pretty simple. I'm going to make this coding even simpler. Before I do that, though, I want you to look at, there are these other values, though. 6 is refused, 8 is don't know, and 9 is not applicable. Okay, so there are some respondents in the data set who did not give a valid response. And so they are coded as missing data. And you can tell that these are coded as missing. If you look over at this column up here where I'm highlighting, where I have my cursor here, where it says missing, you look down and you see, okay, this is coded as missing data. Now, that's a special feature within SPSS so that when you have certain attributes on a variable that you don't want to be including in mathematical calculations when you're running things, like the 6s and the 8s and the 9s won't be averaged into an average. If you run the average, they will be taken out. They'll be indicated as these are additional cases that didn't give valid responses because they're coded as missing. And so it always tells you in this big column over here, what was the coding for the missings. So it sets those aside, so that way, when you're running descriptive stats or running any stats, those numbers, those values, those 6, 8s, and 9s don't get averaged in. It's only the 0s, the 1s, and the 2s. Those are the valid responses. Okay, so that's just something to keep in mind, but it will come into play here when we want to recode this. So if I want to say, okay, I don't really, I think we really just need to know who has done this and who has not. I don't really care the difference between the once and more than once. I want to recode this to, did you do it at all or did you never do it? A 0 or 1, a binary coding. That's all I want to do with this. So in order to recode a variable, what you want to do, you want to go up to where it says transform, up here on the top ribbon. You want to click on that. And you want to go to where it says recode into different variable. Notice there's one that says recode into same variable. Do not do that, because then that will erase and replace your original variable with a recode. You want to keep that old variable, you want to recode into a different variable. So we're using an old variable, the information from an old variable, to make a new variable. So you want to go to where it says recode into different variable. All right, and go ahead and click that. All right, and you should see a little window pop up in the middle of my screen. Did you see that where it says recode in different variables? Can people see that? Give me a thumbs up where a little window popped up, says recode into different variable. Okay, I got a thumbs up from Harley, very good. Okay, so what you're seeing here is over here on the left-hand side is a list of all the variables in the data set. Okay, so what you need to do, what I do in this to make my life simpler is you can right click on this and you can say, I don't want to see the variable labels. I want to see the variable names, and you can make it show the variable names. And then you can make it sort, rather than by file order, you can sort it alphabetically. And then I want to find my variable H1FV5. And so this is alphanumeric order. So it's H1FV5 is what I want to just go down to. And oops. H1FV5 is what I'm looking for. Yeah, just missed it. Okay, and so we find it right here. And what we say, okay, so what I want to do is I want to recode this thing. So I'm going to put this over here in this box. Okay, And so I want to give this a name, and I'm going to call it dummy fight. Oops, just call it dummy fight, because it's going to be a dummy variable to indicate whether or not the student respondents gotten into a physical fight. So I'm going to rename it dummy fight, and I can put a label in here. I can say ever fought. Oops. Yes or no. And then what we want to do is we want to go ahead and hit change. Now the label actually is not necessary for this, but you do have to give the variable a new name. You have to give it a new name, otherwise you won't be able to do what we're going to do next. And remember, when you're naming the variables, you cannot have any spaces in here, extra characters. When you put a label on it, you can have spaces and type a lot more, and so that way it will allow you to give a better description of what you're doing here. Okay, the next thing you want to do is we want to go down to where it says old new values, and it'll bring up this window. And so what you're doing here, you want to say, okay, I want to recode this so that if you have never fought, you're a 0, and in my new variable, I also want you to be a 0. So we want to keep the zeros a 0. So on the old variable, if you had a 0, on the new variable we're making called dummy fight, we want to keep you as 0. And you go ahead and put a 0 on the right-hand side where it says new value, and you hit add. Okay, so what it's saying under here in this little window, it says on the old one, if you were a 0, on the new variable that you're making called dummy fight, you're also going to be coded as 0. I don't want I want to collapse the categories of 1 and 2 into one new category and have it coded as 1. So I'm going to say, okay, if you were a 1 on the original, you're still going to be a 1 on my new variable. But also, if you put a 2, if you said you did it more than once, you're going to be recoded as 1 on this new variable. So you see, okay, so if you had a 0 on the old, you'll be a 0 on the new. If you had a 1 on the old, you're a 1 on the new. If you also, if you had a 2 on the old, you will be a 1 on the new. So now all the valid responses are going to be coded. They're going to be dummy coded style or binary coded style, 0 1s. The last thing we want to do on this is that we want to, we need to do something with the people who didn't provide valid responses. They were too embarrassed, they skipped over the question, they didn't want to answer it for whatever reason. Okay, fine. Sometimes we want to impute values for people who do not provide valid responses. Other times we can't use them in the sample in our study because they didn't tell us, they didn't give us a valid response. Okay, and so if we just want to leave them missing, what we want to do is go down to where it says system or user missing. And so this is the catch-all. Don't pick this one. Don't pick the one that says system missing. Pick the next one down that says system or user missing. So you want to say, okay, if you were missing, if you had a 6 or an 8 or a 9 on that previous variable, on the old variable, then we want to keep you missing on this new variable. So if you're missing here, we want you missing on our new recoded variable as well. We're not going to just make up arbitrarily say that just because you didn't respond to it, we think it's a 0. We're not going to do that. We're going to leave you missing, and we're going to put you and we're going to add it again. You always will have to hit add. And so what it does, it's saying, okay, if you're missing on the original, you're going to be missing. You're going to be sysmiss. You're going to be missing on the new one as well. Okay, and so that is how we do the recode from a variable that's coded with 3-level responses, a 0, 1, and a 2, to now just a 2-level response variable, a binary coded variable. And we hit continue, and then we go ahead and hit OK. And hopefully we don't get any error messages. What it's showing you now is this little output window. And it's giving you this is the output window. So in your assignment, you'll need to save this information from this. But this is this output window. This is just giving you syntax right now. It's showing you what we did. We recoded this variable 0 to 0, 1 to 1, 2 to 1, and then we did the system missing, you'll be recoded as missing as well. And this is the variable called dummy fight. Okay, so that is the label for the dummy fight is ever fought, yes or no. Okay, so we have that in place. All right, so I'm just going to minimize that, and I'll show you whenever you add a new variable will always appear at the very end. It'll be, after the very last original variable in here, the new variables will always be just at the very bottom of the file. It'll be the last variable. The most recent variables that you make will appear at the bottom of the file. Okay, and so here's our label. And now we also, just to be clear, how we coded this thing, let's go ahead and put in value labels here. And so if you had a 0, that meant never fought. I'm going to put that in there and add that. And it doesn't matter that's 0.00. It's okay. You can go in and make it so it doesn't do anything past the decimal, but it's fine. It doesn't matter. If you have a 1, you can put, did fight. Okay, so we know what that means. Okay, so 0, you never fought, and 1, you did fight. We don't know how many times. We don't care for the purposes of this analysis. We're just doing a dummy recode, and go ahead and hit OK. And so now it shows that. All right, and so what we want to do for this is we want to now run a frequency distribution table on the original variable and our recoded variable to make sure we did this right. All right, so what you want to do is we want to go up to where it says analyze. Analyze is the thing that you go to for pretty much all of your actual descriptive and inferential statistics. So we go up to analyze, and then we go to where it says descriptive stats, and then we go over to where it says frequencies for frequency distributions. Okay, and so what we want to do is let's first go ahead and put our recode in there. So we can just scroll all the way down. It's going to be the last variable there. If I show it as display variable names, there's dummy fight. So we want to go ahead, we want a frequency distribution for that variable, and I want to compare this to the original variable. It's a good way to check your work so we can see if we did this right. Let's go up and get the original variable. I'm going to go ahead and sort alphabetically, right click, that will make that come up, sort alphabetically, and we want this variable h1fv5, and we want to analyze that as well, h1fv5. Okay, here we go, and we go ahead and put that over there. There's a bunch of other stuff over here that we can talk about in another class, but for right now, we're just going to get the frequency distribution table. Okay, and so that's already checked, display frequency tables. You go ahead and hit OK. Okay, now can you guys see this output with a frequency distribution table? It should have popped up. Somebody give me a thumbs up if they can see this where it says ever fought, yes or no. Can you see this? Can't see this? Okay, let me see. Stop sharing. Let me go back to share. Yeah, for whatever reason it does that. That's annoying, but we'll get through it. Okay, so you should be able to see that now. So you can see that where it says ever fought, yes, no. Can you all see that now? Yes. Okay, great. So this is our recoded variable. So this is never fought. We've got 60. So let's just start here. This is the frequency. This is the number of people who said that they never have done this. This is 4,410 respondents said that they have never done this. 2,045 said that they did. 6,000, that's out of a total of 6,455 who gave valid responses, but there are 49 missing people. Okay, and so all those added up, that adds up to 6,504. Over here are the percentages out of the entire sample. And it gives you even the percent for the missing. And then over here, it gives you what's called a valid percent. So the valid percent is only out of the total 6,455 that gave valid responses. But because there's only 49 missing cases, this percent is very similar to this percent. This percent is very similar to this percent. If there were tons of missing cases, then the percents could be very different. But the first column percent is just saying out of the total number, the total sample overall, including those that are even missing, where the valid percent is the percentage out of the people who gave valid responses on the original variable. They had to have either said a 1 or 0, 1, or a 2. They couldn't have been missing. And so that's so this is going to be a little bit different. And here it shows you the cumulative percent, remember, is just this percent, 68.3 plus 31.7 equals 100%. All right. And so we want to double check to make sure we coded this right. Right below this is our original variable, got into a physical fight. Okay. So if we kept the 0 zeros, this never fought should match with never. So we got 4, 4, 10, 4, 4, 10 here. Okay, good. We did it right. Then we wanted to collapse categories. So if you had a 1, you get a 1. You have a 2, you also get a 1. So so if we add 1,189 to 856, we do indeed get the number 2,045. Okay, so we did it right. So we can tell that what we did, again, we collapsed categories. We wanted to say, okay, if you did it once or if you did it more than once, we're gonna count all of y'all as just one. And that means this is gonna get this group of people is going to be lumped in with this group of people here, and that does total the value of 2,045 respondents. And so we kept the missing, and so we still have the same number of missing people. 49 are missing here, 49 are missing here, so that's all good. And so that is a recode, and that's what you want to do for your assignment. For the first part of it is that you want to recode that. We want to recode that as a dummy variable. Okay. So let me go ahead and get started with the next one, where I want you to what I want you to do is again, you want to do a recode, but I want you to this is going to be one that's a little bit different, but it's very similar. I know we're getting a little short on time here, but just bear with me here. I want to go into this next example. Are there any, first of all, before I go any further, are there any questions about this that you're like, whoa, what? I missed something. I need you to do that again. Anything? You can always go back and watch this. So I'm recording them. Okay. So I would like to do another one where what we're doing is we are going to go to, again, we want to go to, first, let me get out of this. I want to just show you, before I get ahead of myself, I want to show you the variable we're going to recode. I want to pick a variable that's coded a little bit differently. I'm going to pick this variable that's the title or the name of the variable here. It asks about how close the respondents were to their mother. Okay, how close are you to mom? Okay, so I'm going to go Control F on here. It's a quick way to find the variable. The variable name is H1WP9. Okay, and so H1WP9, oops, I did that thing again where it stopped sharing, sorry. Okay, so I went to this variable H1WP9. This is variable asks respondents how close they are to mother. Again, you can always go back to the original survey if you want to know exactly what language was used in the question. And you can see how this was recoded. Some said not at all close to mom. Some said very little. Some said somewhat. Some said quite a bit. And and for 5, it was coded as very much. And then again, we have missing categories. So we have 6 is refused, 7 is legitimate skip, and 8 is don't know. Okay, so those are missing. So you don't have to worry about those being involved in your calculation. But if you want to recode into a smaller number of categories, if, for example, you want to say, I just want to recode people so that they are 5 and 6 are collapsed into one, or I'm sorry, 4 and 5 are collapsed into one category. And that you have everybody else, 1, 2, 3 collapsed in into another category. So the people who are a little shaky about how they feel about mom, we're going to categorize them. We're going to recode them we're going to recode them as a 0. And we'll recode everybody else as a 1. We'll do this as a dummy variable again, or actually no, I'll do it like this. I'll make 1s and 2s a 0. I'll make 3 a 1, and I'll make 4 and 5 a 2. Okay, so what we'll do is we'll go in to where it says analyze. Transform. I apologize. Transform recode into different variable. It's going to have the original stuff in here that you did just previously. Go ahead and hit reset. You hit the reset to clear that all out. And I'm going to go and display variable name, right click, display variable name, and sort by alphabetical order. And I want to go to where it says the variable name H1WP9, H1WP9. Okay, so we'll say close to mom recode, and then we'll label this 3, I'm gonna say a 3 level, I spell 3 level close to mom recode. So I renamed it close to mom, and then I called the label 3 level close to mom recode. Okay, so change that. Okay, so I always have to change, and then it'll allow me to go into all new values. Okay, so for this one, I want to say, okay, if you are a 1, if you not at all close to mom for whatever reason, I'm going to recode you as 0. Okay. If you were a 2, I'm going to recode you as 0. You always have to hit add to make it go down there. If you were a 3, if you're someone ambivalent about mom for whatever reason, I'm going to keep you, or I'm going to make you a 1 over here. Okay, and then I want to collapse the categories of 4 and 5. The categories of 4 and 5. These are the people who felt pretty good about mom. I'm going to collapse those categories. If you had a 4 over here, I'm going to make you a 2. Add. And if you had a 5 over here, I'm going to also make you a 2. Okay, and then we want to say, okay, if you were missing, if you didn't want to report on this, that's fine, but sorry, you're going to be missing in my analysis then as well. So you want to go system or user missing. You're going to be missing over here on this new variable as well. And you hit add. Okay, and then we go ahead and hit continue and go ahead and hit OK. And I know this is probably had stopped sharing the screen, so, or maybe not. So what we want to do is let me go in and let me minimize this. Can y'all still see my screen, my cursor moving around? Yeah, okay. So we want to go up to where it says analyze and repeat what we did basically the last time. Descriptive stats. Okay, reset this because it always will have the old stuff in there. Scroll down, find, here, display its variable name. Okay, close to mom, recode. We're gonna put that over there. And then we always want to find the original one just to check our work, to make sure we collapse categories correctly. And let me see, alphabetical order. It's the variable, what is it? It's H1 WP9. Is this in alphabetical order? Wait, yeah. Okay, okay, yeah, H1 WP9. Sometimes I forget my alphabet. Okay, H1 WP9. Oh, sometimes. Okay, so send that over there and you hit okay. And I know that probably stopped. Let me stop sharing the screen real quick with you. And we'll bring this up. That's the last thing. Just want to show you this output real quick here, and I'll let you guys go. We'll do the other part from Monday. You can just a second. Let's see. Okay, what is this? Why is this acting weird? Oh no. Okay, here we go. Right. Okay. All right. So, okay. So here's our recode. We forgot, we didn't put in the value labels for this. We can always go back and do that. I just want to show you so that we have these first two categories we collapse together. So 25 plus 156 does indeed equal the value of 181. Okay, so we did that right. We kept the middle score value of 3 as the same. So the one here is, yeah, it's 480, that's the same. And then the two higher scores, we collapse those together the quite a bit and very much. The 1,129, we combine that with the 4,239, and that 1,229 plus 4,239 does indeed equal 5,468. Okay, and so that is another way that you can recode. It's called collapsing categories. You're combining together categories to make a variable that has fewer attributes or a smaller number of levels. Okay, folks. So I'm gonna stop right there. There is one more. There's something called reverse coding. It's really quite simple. It's nothing really any more complex than what we've been doing. We will. I'm going to send a Zoom invite out on Friday to work on this. I will though go over the reverse coding on Monday. The homework is not due until Wednesday. But if you want to, if try this, start working on this, doing the recodes. If you would like to confirm with me that you're doing it right, you have some questions, you can attend the Zoom meeting session on Friday. You are not obligated to go though. There's no participation attendance requirements on Fridays. But the reverse coding one, the part 3 on your homework, we'll cover that right away on Monday. Okay, so that's all for today. You are welcome to go, and that is all. You can stick around if you have any questions for me, but that is it for today. So yeah, so bye-bye. Take care. If you want to come Friday, that's great. I will be here, but we will do that part 3 on Monday for the reverse coding. But I think you should be able to do the first 2. Without a problem. If you're struggling, that's fine. You know, this is your first exposure to this stuff. So come Friday, if you're not like, I don't know what to do. But the video is going to be on Moodle. So take care. Class is over. Have a good day. Have a good weekend. See you Friday if you want.
Professor Sefrin, I have a question unrelated to this course. So for the CJ 351-507,
yeah,
would I still be able to switch over to the graduate portion of that instead of the undergrad? Because I believe the switch has to be in today.
Oh yeah, you want to do that. Wait, what's your grade level? What are you at right now? Are you?
I'm in the 351. I'm a junior.
Oh yeah. What's your GPA? What is it?
3.5 or 3.6.
Oh yeah, you're all good. Yeah, do that right away. What you want to do, I'm going to send you a a registration form, because it's going to block you because you're not officially a graduate student. You need to fill that out. Do that right away. I'll send you the link, because you can't go through the regular registration. You want to do it through that. It'll come back to me. I'll approve it, and then you'll switch over to the 507. Okay.
Okay.
All right.
Thank you.
Care.